So now we are going to develop a project through PictoBlocks software to demonstrate the blood donor to receiver compatibility using Arduino Uno HC05 Bluetooth module, breadboard, and 8 different LEDs to show the recipient blood groups. So for that project, we would need PictoBlock software to be installed. I'm going to open the PictoBlock software, and now we will see how this PictoBlocks application or software can be used along with Arduino Uno board. So here I'm going to click we are going to do block coding. So I'm going to click blocks and not junior blocks. So click blocks. So you are all aware of the interface of PictoBlocks. It is very much Scratch based platform, and here in this particular project we are going to use different blocks here, specifically blocks related to Arduino Uno programming that we are going to use, and we are going to basically use the Dabble application. That is Dabble is PictoBlocks mobile application, which can be used along with the Arduino Uno board for various reasons. In this particular project, we are going to use PictoBlocks software along with Dabble application for serial communication through Bluetooth, so that we can work out on the blood donor to receiver compatibility. In this particular project, this is the circuit diagram, and we are basically going to do this project to demonstrate blood donor to recipient compatibility. So this is a uh, standard blood donor recipient chart, wherein the columns here, they represent the donors, and the rows, they particularly represent the recipients. So what we are going to do is we are going to identify if O negative is the donor, what are the different blood groups that work as recipient. So it is clearly seen from this chart that when O negative is the donor, all the blood groups, right from A, B positive to O negative, are all the recipients. So O negative is a universal donor. O positive, if it is a donor, then AB positive and A positive, B positive, and O positive are the recipients. So similarly, we can understand that when a particular blood group is a donor, what are the blood groups that act as the recipient, which are compatible recipient. So what we have done to represent this particular project, we are going to use Arduino Uno, as I said, the Bluetooth module, that is HC05 module, and we are going to use the Dabble mobile application to basically enter this data. So the user will enter O negative as a donor, and there are different LEDs here that are connected to Arduino Uno board through digital pins from 4 to 4, 5, 6, 7, 8, 9, 10, 11. So 4 to 11, there are 8 LEDs, so which are basically representing the recipients. So ideally, when O negative is entered by the user, all the LEDs which represent AB positive to O negative in this particular row will turn on, because O negative can donate blood to all the types of blood as recipients. So similarly, when the user enters O positive as a blood donor, so the LEDs that are representing basically AB positive, then A positive, so that is AB positive, A positive, then B positive, that is this LED, and O positive, that is this LED, will turn on. So similarly, you can understand rest of the logic here. So we have connected the HC05 Bluetooth module through TX-RX. Pins are connected. So the TX pin is connected to digital pin number 2, and the RX pin is connected to digital pin number 3. VCC and ground are connected to 5 volt and ground respectively, and each LED is given a common ground connection through the breadboard, as shown in the circuit diagram. So we'll keep referring to the circuit diagram on and off throughout this particular project when we are going to write the block codes for this particular program. So I'll go back to PictoBlocks. So what I will be doing is I'll be needing to connect the Arduino board to my laptop before I basically start using the Arduino Uno blocks. You might be aware of rest of the blocks in Scratch or PictoBlocks, but here the Arduino blocks are not visible unless we connect the Arduino board. I have already connected my laptop to the Arduino Uno board in this particular video, as I already have shown it. So let me select the board. So Arduino Uno board we are using, and then we need to select the port. So currently I'm connecting Arduino Uno through COM5 as it is seen here. So I'll connect. So it is showing serial port connected. So as soon as I have selected the serial port, you can see Arduino Uno blocks are activated. At the same time, I can have different blocks, but primarily Arduino Uno actuators, the dabble, specifically dabble extension gets activated, which we would be using in this project. So in this particular project, we will be using mostly Arduino Uno blocks and then dabble blocks. So what I'm going to do is I'm going to basically keep referring to the circuit diagram, but before we start with the program, so to start with writing up different blocks of Arduino Uno, what we need to be doing is we need to there are different modes here while using PictoBlocks. As you can see, there is stage and upload mode. We need to switch from stage mode to upload mode. So I'm going to click on the upload mode, and then upload mode will be activated, where you will see the code written in C plus language as that of the Arduino IDE. Now I can drag the Arduino block. So the first block that we need here in this project is when Arduino Uno starts up. What should happen? We'll go to dabble. We need to set Bluetooth rate to 9600. We have seen this in Arduino IDE projects. So we set the Bluetooth rate to 9600. Then what should happen is, if I'm going to use if block, and if there is a particular value entered through the dabble application serial communicator through Bluetooth, what should happen? So for example, I need to go to dabble. So if there is a data from terminal, if data from terminal is something, then what should happen? So let's see. So if our data from terminal is O negative, okay, because we are trying to find out recipient for O negative as a donor. So what are the compatible recipients we need to identify? So if the entry through dabble is O negative, so I'm going to write O negative. What should happen? So we are going to set some pins high and some pins low. So right now I'm just going to add 8 pins here. Okay, you can copy the block. I'm just going to copy these blocks together. So we need 8 digital pins: 1 2 3 4 5 6 7 8. So if the data from Bluetooth is O negative, all the LEDs should turn on. So all the LEDs which are connected to pins from D4, digital pin 4, 5, 6, 7, 8, 9, 10, 11. So 4 to 11, all pins should turn on. That means they should be high to turn all these LEDs on. So for O negative blood group as a donor, the recipient blood groups like AB, compatible recipient blood groups like AB positive, AB negative, A positive, A negative, B positive, B negative, O positive, O negative, all the LEDs will turn on. So all these digital pins to be set to high. So right from digital pin 4, we can select pin numbers here. So digital pins 4, 5, 6, 7, 8, then 9, 10, 11. Right. So digital pin 4 to 11, we are going to turn high. Now I'm going to copy entire if block and place it here, not inside this if. I'm going to place it outside this if, because there is something wrong here. Okay, so I'm just going to copy this entire if block and paste it here. We are going to copy entire block. We can copy so as to save on the time. So a user can type O positive or O negative as O capital or O small. So let us give O negative also as entry. So even if the user enters O negative, that is O small, still it can be considered as O negative blood group here, and it will identify the compatible recipient groups. So I'm just copying that. Now the next blood group should be O positive. If the entry is O positive, what are the pins that needs to be turning on? That is AB positive, then AB positive, A positive, B positive, and O positive, all positives. So 4, pin number 4, pin number 6, pin number 8, pin number 10 should basically turn on when the entry is O positive. So let me go back and I'll copy this, duplicate entire thing here. You need to be careful while you place the blocks because they can accidentally be placed inside anywhere. So if the entry is O positive, so I'm going to keep it capital O positive. So 4 should be high, and 4, 6, 8, 10 should be high. So I'm going to make 7, 9, 11 as low. So pin number 4, when the entry is O positive, pin number 4, 6, 8, 10 should be high, O positive. Pin number 4, 6, 8, 10 should turn on to represent all the positive blood groups. I'm going to again copy this thing to take care of the if somebody writes small letters as O positive, sorry, this is O positive. So we are done with O positive, O negative, O negative, O positive, and O positive. So we are done with first two donor blood groups. So when it comes to B negative as a donor blood group, the LEDs that need to turn on are basically AB positive, that is 4, then AB negative, that is pin number 5, B positive, that is 8, and B negative, that is 9. So 4, 5, 8, and 9. So that I'm going to basically turn it on. So I just copy this and again duplicate and so B negative. So B negative. So 4, 5 should turn on. So 4, 5, and then 8 and 9. So B positive and B negative, that is 9. So 4, 5, 8, 9. 9 should also be on, then low. So 4, 5, 8, 9. I'm going to again say duplicate and add that here for capital B negative, so that if someone accidentally types capital B negative, it should do the same output. So that is B negative. Then B positive, only 2 pins, LED pins to turn on, that is AB positive, that is pin number 4, and B positive, that is pin number 8. So 4 and 8 to be only on in that case. Okay, so I'm going to duplicate this and I'm going to attach it here. So when the entry is B positive, so pin number 4 and pin number B plus is 8. So 4 and 8. So all other are low. So 4 and 8. So 4, that is AB positive, and then 8 as B positive will turn on when the entry is B plus or B positive. I'm just copy this entire, rather duplicate entire block here and then I'll just write it B positive in capitals. Okay, so we are done with B positive. Then we'll go to A negative. So when the entry is A negative, AB positive, AB negative, A positive, A negative. So the first, four digital pins, 4, 5, 6, 7, to turn on to represent AB positive, AB negative, A positive, and A negative as the recipients of A negative blood group as a donor. So we are done with B positive, B. Then we will copy and we will write A negative. Okay. So first four pins from 4, 5, 6, and 7. So when there is A negative, so pin number 4, 5, 6, 7 should turn on. Let us see, yes, and let us make all the pins low. Okay, 4, 5, 6, 7, 8 is also to be turned low. 8 is nothing but B positive, so only until A negative. So that is A negative is D7. So 4, 5, 6, 7, 4 pins we made on, turn high. Then I'll just duplicate this if the entry is A negative in capital. So then A positive. So for A positive, pin number 4, that is AB positive, pin number 4, and pin number 6, that is A positive. So only these two pins to turn on. So 4 and 6, rest of the pins are low. So I'm going to duplicate again and I'll just attach it here. So that is A positive. So only 4 and 6, the rest of the pins are low. Yeah, 4 and 6. So 4 high, 6 high, 5, 7, 8, 9, 10, 11 low. And I'm going to duplicate this, attach it here. For A positive in capital letters. So again going back here, AB negative, so that is AB positive and AB negative pins should turn on. So these are basically 4 and 5. So first two pins 4 and 5 to turn on if the donor blood group entry is AB negative. Okay, here in this case, let's see, it is going to be a little interesting. AB negative, so it is going to be only first two pins to turn on, the rest of the pins are low. Okay, so first two pins turn on. What I need to be doing is I'll be duplicating it, and here it is 4 different combinations. So somebody can write AB, both small letters, both capital. There is another chance that somebody will write A small, B capital, and the other possibility is somebody may write A capital, B small. So there are 4 combinations, both small, both capital, one small and one capital. Okay, so there are 4 combinations. The logic remains same, and the last blood group is AB positive, for which only one pin, that is AB positive pin, that is pin number 4, should turn on. So what I'll do is I'll just copy this block, duplicate and connect. This is where I'll do AB positive and one pin to turn on, it is this, and rest of my job is easy. Duplicate, and as I said, you need to be careful with attaching these blocks. Okay, all capital. I duplicated it. So A small, B capital, again duplicate. The last entry is A capital and B small. So this is how our program looks like for all different combinations, and we want this to be actually in happening in loop, as that of, we use while loop in Arduino IDE software. So for that to happen, we are going to use a block called as forever. Okay, go to control and just put everything into forever block. Okay, so right from here to the last block, rather, yeah, we need to verify everything until the last block is put into the forever block. So this is our code. We are almost done. So you can see that the same block coding has been converted to the C++ code. Now what we are going to do is we are going to upload this code to Arduino IDE. So let me upload that. Click here, upload code. Okay, I need to select board again, maybe Arduino, yes, connect. I've connected, and then I will upload the code. So you will see this progress. And you can see the code being uploaded to Arduino IDE. Upload successfully. Okay. Now the code has been uploaded to Arduino IDE. How to basically use the Arduino IDE setup along with Bluetooth module and Dabble app mobile application is shown into the another video. So please use the another video to see how the Bluetooth device has to be used along with the Dabble mobile application to see the compatibility between donor and recipient. And we can save this project as, we can save this project. We'll save this project as blood donor recipient, okay, demo. Project saved. Thank you very much.